In this video, I will explain you what is scattering of light. Now, with one example, I will explain you this, where light is coming from sun. Okay, from sun, light is coming. So, we know white light is coming. It has violet, indigo, blue, green, yellow, orange light. All the 7 colors. 1, 2, 3, 4, 5, 6, 7. So all the colors are coming together from sun to earth. Now we know that out of violet, indigo, blue, green, yellow, orange, red, violet is having the minimum wavelength. Okay, and this is having, red is having the maximum wavelength. So this is red and this is violet. Violet wavelength is less and red's wavelength is more. Now when this meet a dust particle, so I have a dust particle here and I have the same size dust particle here. What will happen here? So here the light ray cannot pass over the dust particle. So now at dust particle scattering will happen. So scattering is nothing but at dust particle this ray will get reflected. So this will come in this way and scattering will occur. So it would go after reflection or after scattering, it would go in this direction. And so this is about one violet ray. So similarly there would be n number of violet ray. So at different particle, after scattering, that would go in backward direction, some random directions. Okay, so violet color rays are going in this direction. What will happen to the red? See, for red the ray can easily pass over. See, for a red, if this is the dust particle, if the wavelength is more, it can simply pass across the dust particle. But in the case of violet and blue, their wavelength is so less, so that scattering would occur. So after scattering, that would go to different direction. So this is simply reflection on the dust particle. Okay, now this is earth and sun. Now from sun, I can say that red color light would simply come without any scattering. Now when we are looking direct to sun, we can see red color light or orange or yellow or mixture of these colors coming from sun. So sun seems to be like, kind of reddish color, and around that we can see yellow and orange color, because the yellow, orange, red, these areas are having higher wavelength and without any scattering that can directly reach our eye, from sun direct to our eye without any scattering. But what will happen to blue? On reaching the particles, dust particle, that would get scattered in random directions. So it is in backward direction. So see, backward, get scattered here, get scattered here, get scattered here. See, now here we have another layer. Even again we have dust particle, sky particle. So what will happen? From here this would get reflected back again to our eye, So see, a dust particle that would get scattered, and again with another dust particle that would be reflected. See, from sun, from here scattering occurs, another dust particle reflected. See, from sun, so here I have sun, here I have earth, violet color light comes being scattered and from here being reflected and reaches our eye. So this is the reason when we look sky seems to be in blue color. The reason is from sky the color coming is violet, indigo, blue, these ranges, but blue is more sensitive to our eye, so we are catching more number of blue color light than violet color light. So the reason is blue is more sensitive for eye, though we have combination of violet, indigo, blue. since the blue is more sensitive to our eye, we see sky in blue color, because this scattered, after scattering they would go in different direction, and from there again that is being scattered and that is received to earth, and what we are seeing is blue color light coming from earth, but actually this is being scattered and again scattered and reaching our eye. But when we are directly looking sun, we can see yellow, orange, red, these kind of colors, because they are coming directly towards us. So we have seen that higher the wavelength, lesser is the scattering, lower the wavelength, more is the scattering. So actually Rayleigh has put it in a law. He told that intensity of scattered ray, so intensity of scattered ray is inversely proportional to 1 by lambda power 4, where lambda is the wavelength. So lower the lambda, lower the wavelength, lambda power 4 would be scattering. So from 4, if the wavelength is brought to 2, what is the change? 2 power 4 is the change. Okay, so a small drop in wavelength would be a large increase in wavelength. Sorry, large increase in scattering. So smaller is the wavelength, larger would be scattering. Red is having least scattering, violet is having highest scattering. Now I will also explain you the reason why we are using orange color light in the case of fog lamp and red color warning signal, warning. Now red color for warning signal is, red is subjected to least scattering. Now when we see red color light in the traffic signal, see that would be subjected to least scattering, which means that can directly reach our eye without being scattered. But if you are using blue, that would be scattered around, so that cannot reach our eye. And why we are using orange color in fog lamp? Why can't we use red color in fog lamp? See, we know that energy is equal to h nu or hc by lambda. Now if the wavelength is higher, energy would be less. So red color has got lower energy but lower scattering. So this won't be scattered, but the problem here is that cannot go to larger distance. The problem is on reaching the surface or earth surface, that is being immediately absorbed by earth, so that the red color cannot go to larger distance. That has very less scattering, but the problem is they have got very less energy from this equation. But out of violet, indigo, blue, green, yellow, orange, red, next to red I have orange. So orange will also have comparatively the same scattering power as compared to red, which means that would be subjected to very less scattering, but their energy is more because wavelength is less as compared to red. Lower the wavelength, higher would be the energy. So it has energy, at the same time it would be subjected to no scattering, or I can say less scattering. That is the reason we are using orange color in fog lamp. Okay, red color reason is no scattering, so it can reach larger distance. Orange color again less scattering, it's not no scattering, less scattering, but has got higher energy as compared to red, so it can go to larger distance. Now blue color for the sky is simply scattering, because what we are seeing is blue color coming from the dust particles. Okay, so sky appeared to be in blue color. Okay, thank you.